mean?
It means you're slowing down.
Yes, exactly. Yes, the rate of change of distance with respect to time. In other words, the velocity is decreasing. Yeah. Okay, very good. Let's move on. So we finished this. The graph, we're gonna, if you want, we're gonna put them in the graphing calculator and graph all of them. Final part. When is the particle speeding up and when it is slowing down? Okay. So,
Professor,
yes?
maybe I'm making a mistake, but I'm getting something different because I got 1 squared is 1 minus 4 plus 2. That would be 2 times e to the negative t, e to the negative 1. Am I doing something wrong?
Maybe I am. Maybe I am. So 1 plus 2 is 3. 3 minus 4 is negative 1. Negative 1 times e to negative 1.
Oh, no, yeah. For some reason, I just thought that t squared or 1 squared was 0. So sorry about that.
No, I'd rather go back and check. Again, you may see something I don't. I'm not like that driver. I drove with some people, and if you say something like look at that or watch out or something, they explode. I can say no. When somebody drives with me, I always say, if you see something, say something. Maybe I don't see it. So it's never a bother, please. Okay, so it was one more time. 1 plus 2 is 3. 3 minus 4 is negative 1. And this is e to negative 1. I think I'm okay on that. Okay, so final question, number 8. So they're asking us, where is the particle speeding up or slowing down? Okay, that's the reason why I asked. We understand that when the velocity is negative, the acceleration, when the acceleration is negative, the velocity is decreasing, right? And that's what it means. Okay, so now let's think about 2 scenarios here. You're riding your bike, and let's say you can do 30 miles an hour. Good for you. That's the maximum speed you can ride your bike at. Let's assume that. So here is you on a bike. I cannot draw that, of course. You're going in this direction, but you encounter a headwind of 5 miles an hour. What will be your actual speed?
$25 miles per hour.
25 miles an hour. Here's a different scenario. We're going in this direction, but this time you have a tailwind of 5 miles an hour. What is your actual speed now? Anyone?
Someone said 35 miles per hour.
Oh, I didn't hear. I did get a warning about my internet for a second. Okay, perfect. Excellent. So, in other words, if 2 forces work against each other, the particle will be slowing down. If these 2 forces work towards the same direction, they are in the same direction. If here one is positive and one is negative, the particle, we realized, is slowing down. But here they have the same sign. They work together. This particle will be speeding up. So we are definitely talking about the velocity and the acceleration. I don't know. So we have to assume that this is still the case between 0 and 6. Okay, 0 and 6. So we have the velocity here. Of course, we have the acceleration. We already know that at 2, the velocity is 0. At 0, the velocity is 0. We already know that this is the sign. We studied it before. But now we have to do the same thing with the acceleration. So the acceleration, this part is always positive. We want to solve this equation, set it equal to 0 to find the solutions. So I'm going to share my screen and go directly to the calculator and go to that app, and 9, and it's quadratic. Yes. So now I want to punch in the coefficients. So the first one is 1. The second one is -4. And the last one is 2. Okay, and solve. So 0.59 seconds and 3.41 seconds. So A of t is 0 when t equals 0.59 seconds and when t equals 3.41 seconds. Okay? So I have to put them in. 0.5.
Will we have to do that whole calculator thing you just did? Because I personally have no idea what you just did.
I solved the equation t squared minus 4t plus 2 equals 0, as t equals -b plus or minus b squared, -4, +4, negative b plus or minus 16 minus 4ac over 2a, the quadratic formula. You can just use the quadratic formula. You don't have to use what I just did. I'm saying that in calculus, I accept that in the hope that everyone knows the quadratic formula by now. So if you punch this in the graphing calculator, you will get the same solutions. Do you understand the steps here?
Yes.
Perfect. So let me show that. So if you don't want to use this, then you will carefully put parentheses around the top. 4 plus the square root of 8. Against all my convictions, I did not use parentheses under the square root. I'm upset with myself now. Okay, that's one solution, and the other one, just change that to minus, overwrite it, and we get this. Is this okay? So 3.41 and 0.59. Your calculator, actually, I'm very glad you said that, because your calculator may not have that feature. It doesn't have to. But if your calculator has that feature, please use it, because I'm not really expecting you to write the quadratic formula anymore. I think that's done and over with. Okay, so 0.59 is somewhere here. And 3.4 is somewhere here. And now I have to study the sign of the acceleration. Here is the acceleration. I will not study the sign of this piece because it's always positive, as we know. I will study the sign left and right. So when I plug in 0, this is positive. When I plug in 2, I get 4. Plus 2 is 6, but this is -8. I don't have to do this. I know this is quadratic, so this has to be positive again. So if I plug in 6, 36, this will cover it, so this is it. So I know the sign of the velocity, I know the sign of the acceleration. So now I see problem has 1, 2, 3, 4 subintervals. Okay. On the first subinterval, what does the particle do when the velocity is positive and the acceleration is positive?
Speeding up.
Very good. Speeding up. Next subinterval, between 0.59 and 2. What does the function do when the velocity is positive? My car is still moving, but I am decelerating. So velocity positive, acceleration negative.
Slowing down.
Slowing down. Moving on. The velocity is negative, the acceleration is negative, between second 2 and second 3.41. What does the particle do?
It's moving to the left, slowing down.
So they are both going this way. They are helping each other. The velocity is negative, the acceleration is negative. They're
Oh, so
not
it's
working.
speeding up.
Yes, they're not
left.
working in opposite directions. They're not impeding each other. They're just simply going back. Okay. Final step. The velocity is negative, the acceleration is positive. Is it speeding up or slowing down?
Slowing down.
Slowing down. I know this was a big problem, but it taught us a lot. Any questions on this?
Yeah, so velocity is the derivative of the equation, and acceleration is the derivative of velocity, right?
Correct.
And velocity is just which direction it's moving, but acceleration is if it's moving at all.
The acceleration, it's a very good question. So if the acceleration is positive and the velocity is positive, the particle will be speeding up. So imagine that so what is the acceleration, in fact? Is the rate of change of this. So in another way of saying what the acceleration is, so let's suppose we see Microsoft stock going up. So the rate of change is positive. But if you look at the rate of change of the rate of change, and if that is positive, then you expect in the future to still go up. But if the stock goes up, but you determine that the rate of change is this time of this is a negative, then it will eventually slow down. So it's not increasing at the same rate. It's increasing at a negative rate. It's still increasing, but it may crash. So coming back to the particle, the velocity is increasing and the acceleration is positive. It's adding to this. The velocity is increasing, but the acceleration is negative. It means that this rate is not increasing. The rate of this is not increasing, but the rate is decreasing. So I still have a positive speed, but the rate of change of the speed is negative, which means I'm slowing down. So this function is the rate of change of the velocity. It tells me that if the velocity it's still because I'm still moving, right? I see the traffic light is red, right? My velocity is still positive, but its rate of change is negative because I'm slowing down. I'm not sure if that's fully clear. But if the velocity is positive and I'm increasing, I'm accelerating, then the particle is speeding up. But I can increase my speed, but if its rate of change is negative, then I will eventually stop. So yeah.
To help like me understand, if we were to apply it like you driving,
Yes.
Between interval 2 and 3.4, you'd be going home, but you'd be speeding up.
Exactly.
Going home.
Exactly. Exactly. So it's the same mechanism with here, but in the opposite direction. Because these two are helping each other. They are not working against each other. If they work against each other, the particle is speeding up. If either one, if they have opposite signs, right? If either one is positive and the other one negative, then the particle is slowing down. But if they are working together, regardless of which direction, then the particle is speeding up. So this is the rate of change of my speed. If the rate of change of my speed is positive, then I increase my speed. But if the rate of change of the speed is decreasing, is negative, then it means that I'm decreasing my speed and eventually stop if nothing else changes. So analysts look at these situations. Any questions? Is this better?
Yeah, I think I understand it a bit more now.
Okay, perfect. Other questions for me?